Test. 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 Alright, it sounds like trash just because this mic is trash. But it should work for the purposes of this course. Or for the purposes of me documenting this course. Okay. Let's see. Is my internet crapping out? No, not right now. Let's see. Anywhere I can post my anywhere I can post my link. All right, very few. There's been very few people posting self-promo. Actually, no one. There's been no one. Wow. Ah. Oh, and I still don't have permission to self-promo on Highcast. Loggers, why am I even on this server then? Just to be on it? Alright. See, last one was 227. Okay. Actually, not bad. Not bad. Oh my gosh, bro. Literally freaking... When is... July. Literally, people haven't promoted themselves since July. Kinda nuts. Okay, this guy's on that grind. Sorry if I'm not... Sorry. I'm not, like, there yet. I'm not on the stream yet, just gonna... Just promoting my stuff here. And yeah. That's it, that should be it. Let's continue. Okay, so I don't know how well I'm gonna learn from this guy. But I'm just gonna try this course anyway. I feel like watching a YouTube video would be like much better. But I'm gonna try this. I'm gonna try this anyway.
Okay, in the previous video we have seen some of the basic possibilities of the scene view. The scene view is very important because it is going to help us
But
to
let's
create
go.
something
Yeah.
essential in Unity, the scenes, okay?
Okay, let me just pause it. But let's go. Okay, that was just for the YouTube video, poggers.
In the scene view, now we have only this cube, and as you can
And
see,
my
we have
eyes
selected the translation tool.
are
So this means that we
dry.
can move our cube in any of the main axes, okay? Okay, so when moving the cube or when performing transformation on the cube, we have two possibilities. We can use the global coordinate system, which is the one it is now selected. As you can see in this button, it says global. This means that this gizmo, these arrows, okay, they are aligned with the global coordinate system of the scene, okay? So this is one of the possibilities. But if we switch to local,
Sure.
this means that we are able to move the object using what we call the local coordinate system. What is the local coordinate system? The local coordinate system is a coordinate system that belongs to the object. So for example, if I rotate the object, as we are going to see, and I select again the translation tool, you're going to see that this local coordinate system is different to the global coordinate system, okay? So the global and the local coordinate systems now are different. So this is very useful. Sometimes you want to move the object using the local coordinate system or the global coordinate system, depending on the situation. You can switch them using this button we have here, okay? This is going to be obvious whenever you rotate the object. When you rotate the object, you're going to see that the local and global coordinate system are going to be different. Every object in Unity is going to have a local coordinate system, and you can switch this local or global whenever you want to manipulate your object, okay?
Sure.
Next to it, we have center or pivot, okay? Center means that, for example, when we want to rotate our object, this object is going to be rotated around the geometrical center of the object. If you select pivot, this means that we are going to rotate the object around the pivot. What is the pivot? The pivot is a point that normally the designer of the object has indicated in a specific position around the geometrical center of the object.
Oh, sure.
If you select pivot, this means that we are going to rotate the object around the pivot. What is the pivot? The pivot is a point that normally the designer of the object has indicated in a specific position. In this case, the pivot is exactly the center of the object. But when we import 3D objects from other softwares, other applications, maybe depending on the designer, you're going to see that the pivot is going to be a different point. And sometimes it is interesting to rotate or to scale around this pivot instead of the center. Okay, so this is the object of this option we have here. Okay, now we are going to do something much more complex. Imagine that this cube is a brick of a wall. So imagine that we want to create a wall. So what I'm going to do now is to start over. So I'm going to create a new cube, okay? Of course, as you can see in the transfer component in Inspector,
what the heck,
the position, the rotation, and the scale of this cube. And we can change these values numerically, okay? So we can put something, of course, here in order to change the position, the rotation, or the scale. So it is not necessary to do it visually. Sometimes it's going to be much more accurate to put some values, fixed values, in the transfer component of the object, okay? So now imagine that we want to create a cube.
This guy says it okay so much.
If we want to create a wall using this cube, one possibility is to create another cube, okay? So now we have two cubes. Imagine they are bricks of a wall. So now using the translation tool, okay, we can move this second one, okay, and put it next to the other. The problem we have is when creating a wall, the problem we have is that, well, we don't want gaps, we don't want overlaps between these two bricks, okay? The overlaps and the gaps are going to be problematic. They are going to be annoying because sometimes even using the physics engine, we are going to have many problems, okay? So it's not just something visually unpleasant for the player. Sometimes it's going to have some drawback, okay, when we execute our game. So we have to avoid these gaps or overlaps. How can we do that, okay? Well, one way of doing that is going to edit and to use the snap settings options we have here. So we can use the snap tools, as we are going to see. By default, as you can see, we have 111. This means that when we use the snapping tool, we are going to move in 1 unit. In Unity, the units are meters, okay? So this means that if we use the snap tools, we are going to be moving 1 meter, okay? This is very important, okay? We can select, for example, this cube. As you can see in the Z coordinate, we have now 1, 3, 8, 5, and we can say snap all axes, or we can snap one of the specific axes. And as you can see, because 1 is the unit, we are forcing this cube to be in a multiple, okay, value from 1 in this case, okay? This is one possibility of this tool, okay, to force,
sure.
To snap, okay, one of the 3 axes or all the axes. Another possibility is we can put here something. In this case, we are going to
Is this like super necessary for me to learn right now? Like, is this actually super necessary? Snap settings, where is that? Game object. Game object. Component. Component. I speak correctly, please. Where was that?
This cube, as you can see in the tools, so we can use, okay, so it's not just something visually unpleasant for the player. Sometimes it's going to draw back, okay? Well, and to use the snap.
Edit. Grid and snap settings. Alright. Sure. So if I do this, there's nothing. Alright. But if I duplicate, then, aha. And then okay, that is not what I meant to do at all. Forgot I have to do this. Wow. That's crazy. Now it looks like one rectangle. But like, why would I want to do that? Can I, wait. Is there not a, okay, is there seriously not like a hotkey for this? I guess I'll learn it later.
Settings options we have here.
Whatever.
So we can use the snap tools, as we are going to see. By default, as you can see, we have 111. This means that when we use the snapping tool,
this is an older version of Unity.
In Unity, the units are meters, okay? So this means that if we use the snap tools, we are going to be moving 1 meter, okay? This is very important, okay? We can select, for example, this cube. As you can see in the Z coordinate, we have now 1, 3, 8, 5, and we can say snap all axes, or we can snap one of the specific axes. And as you can see, because 1 is the unit, we are forcing this cube to be in
I got it. This is just precise movement. It's not actually like, it's not actually snapping anything. It's just precise movement.
Value from 1 in this case, okay? This is one possibility of this tool, okay? To force.
Can I go on YouTube?
Snap, okay? One of the 3 axes.
See this on YouTube?
Another possibility is we can put here something. In this case, we are going to leave the default value 1 meter. And when moving a cube, we can press the command key in Mac or control key in Windows.
I
and
can.
By pressing this key, now when we move, we are going to be moving, okay? We are going to be moving 1 meter exactly, okay? So again, the command key, as you can see, because 1 is the unit, we are forcing this cube to be in a multiple, okay, value from 1 in this case, okay? This is one possibility of this tool, okay? To force, to snap, okay, one of the 3 axes or all the axes.
Okay, wait, what is this guy saying here? Command D, duplicate an object. Select an object plus key V. What? Whatever.
Another possibility is we can put here something. In this case, we are going to leave the default value 1 meter. And when moving a cube, we can press the command key in Mac or control key in Windows. And by pressing this key, now when we move, we are going to be moving.
Okay,
1 meter exactly. Okay. So again, we can.
Wow, ooga booga, ooga booga, fire. Ooga booga. I've never seen anything like this in my whole life. If I, okay, now it's gonna go by increments, got it.
We can snap this object, okay? And now we can, you see, we can be sure that we are moving 1 meter, okay, in each direction, that we are moving 1 meter, okay? And now we can, you see, we can be sure that we are moving 1 meter, okay, in each direction. 1 meter,
Okay.
okay.
What did he do
And
to do
now
that?
select this there, exactly, okay. So again, we can select the snap setting tools. We can snap this object, okay. And now we can, you see, we can be sure that we are moving 1 meter, okay, in each direction. 1
Oh,
meter,
okay.
1 meter, okay. Because the cube, the size of the cube is 1 meter, we are going to be sure that there are no gaps or overlaps between these two cubes. We can use another option we have in the editor, in the scene view, is to use Control D in Windows or Command D in Mac in order to create a duplicate. So we select this one, and with Command D, okay, or Control D in Windows, we can create a duplicate. Now, if we press Control or Command, we can move, you see? And now we are sure that we have now 3 bricks of the wall where we don't have overlaps or we don't have gaps between them. Okay, I'm going to repeat the process. Control D, Command D, and now I press Control Command, and okay, we can put another one here. Control D, Command D, Command, another one.
Is that it?
Repeat this process, okay? So in this way we can, as you can see, we can create a kind of wall, okay, using these bricks, these cubes, and we can be sure that we don't have gaps or overlaps between them. Something very important when we are creating complex scenes. There's another possibility, okay? There's another possibility, and this is what I'm going to do now. Imagine that now I'm going to move it freely, okay, in a specific position. There's another tool, it is called the snapping tool, okay? In this tool, we are going to be able to match, okay, one vertex, okay, into another vertex. So sometimes this is going to be very useful.
This guy says okay
one
so
specific
much.
vertex of an object matches another vertex of another object, okay? So this is really difficult if you want to do it visually, okay? Even numerically can be also very difficult, but we have this snapping tool we are going to use now. This snapping tool works in a very easy way. You have just to press the key V, okay, and keep it pressed, okay, and now you can move, okay, and by moving you can select the origin vertex, okay, in this case, for example, this one, okay. Now I can press the left button.
Hold up, what?
Okay. So this is really difficult if you want to do it visually, okay, even numerically can be also very difficult, but we have this snapping tool we are going to use now. This snapping tool works in a very easy way. You have just to press the key V, okay, and keep it pressed, okay, and now you can move, okay, and by moving you can select the origin vertex, okay, in this case, for example, this one, okay. Now I can press the left button, and now I can move into the other vertices of other objects, as you can see, in this case, for example, here, okay, and I can release all the keys, okay, and now I'm sure that I have put the vertex of this object in the exact position of the vertex of this object, so they match perfectly, okay, so they match perfectly.
Okay.
I'm going to do it again.
Okay.
I'm going to create another duplicate of this object. I'm going to move it freely.
Okay.
I'm going to put it, for example, here. So imagine that again, I want to match this vertex into this vertex, okay? So I select this object, I press the
V,
and
got
I keep
it.
it pressed.
Nuts. That's nutty, bro. That is crazy. That's crazy. Except it's not working now. I don't know what I did wrong. Okay. Let me just make a new cube. Control D. Okay, why is it not working? Oh, that's why. Okay, but it's... Okay, let me just delete this. Perfect. Okay, V. Now I do that. Whoa. That's crazy. Why is there a light here? I don't really want that there. Okay, but cool.
And now with the left button, I press now and the destination. This is the destination, or this, or this, or this, or this. For example, this. And then I release the V key and the
I
button.
press now and I hold to the
So
destination.
Now, again,
Great.
as you can see, these two vertex are in the exact same position, okay? So the snapping tools are going to be very, very useful, and you have to practice them, because with them you're going to be sure that you are not going to have something very annoying, gaps or overlaps between objects. This is very annoying sometimes, especially when we use the physics engine, and sometimes, well, because we are going to see these gaps between the objects when we play the game, and this is not something we like, of course, okay? So now it's your turn. You have to practice them, okay? Because they are very, very important when we are creating complex scenes.
Right. Amazing. Nothing. Nothing else. Okay. Hand tool. Object manipulation. Okay, now they're gonna tell me other ones? Great. QWRT. Hand tool. The other three tools allow object manipulation. Move key, rotate, and scale. Okay, sure. Hand tool. Hand tool. Move. Okay. Oh. I see. Hand tool. Move. Okay. Scale. Oh, my brother. Got it. Scale. Rotate. Oh, E is rotate. QWERT. T is like proportional scale, I guess. Can I not scale? Oh. Okay. Sure. Alright. Fair enough. Q is just look around. Even though I can do that with middle click, so I'm never going to be pressing that. And left click is rotate camera around myself. Alt hold is rotate around the center point. Like, which is right in front of me. Got it. Okay, so W, move. E, rotate. There's also free rotate. Got it. Okay, then these are along. These are relative? No, not relative. Oh, local axis. Okay, got it. Never mind. Okay, so I am probably gonna find out what the hotkey is for that. So, whoa. We got scale, then we got proportional scale. Oh, wait. Hold up. Hold the phone, bro. Wait, that's also just a move key. It's it's not just scale, it's also a move key. And if I do this, then I can scale it this way. Bing, bing. Okay, what is going on? Okay. Nice. This is actually what it looks like. Alrighty. Okay, can I please... Okay, I gotta get used to that. I really gotta get used to that. Can I grab? Can I please grab? Okay, or I could just do this. Did I feel like I messed up my... Oh, I see. It's because it's not... I don't know why it does that. But it like scales the camera movement to the distance, I guess. Okay, now I completely messed this up. Can I just get this like next to that, please? Nice. Okay. Okay, can you please just get next to that? Can you get back? Can you just like get back next to that? Okay, it's just making it go super far away. Yay, I did it. Yay. That was really difficult. I could have just made another one. Made another cube or whatever. Okay, bang, and let me just... Okay, got it. Huh. Change the transform component of the game object. Create a game object and modify its position, scale, rotation, getting familiar with their possibilities and observing the inspector view values of the transform component. Alright, fair enough. Experiment the effect of pressing the spacebar plus shift and creating and selecting an object and pressing F. Or double click. Okay. Does this not do the same thing? No? I mean, yes, this does do the same thing, but um, it's weird. It's like the weird way to do it. Okay. I don't know why that did that. Can I please? Got it. Space Shift F. Sure. Pivot slash center. Sure. Local global. Experiment the difference differences between pivot slash center. Okay, rotate is going to have the biggest effect, I feel. So that is going to be the center, and that's the same. That's literally going to be the same. For a cube, all of them are going to be the same. Okay, let's make a new, I don't know, quad? What the fudge? What is that? That just looks like a plane to me. Oh, it's a special plane. It's a plane only from one side. Okay. Yeah, anything symmetrical like this is not gonna have a different terrain. What in the world? No thank you. And the quad is invisible. All right, let's do a plane. Let's see, text mesh pro. No, no, delete that. Delete that. Can you delete, please? Thanks. I don't know how that's a 3D object, but okay, I am apparently not at the level that I need to be to create a ragdoll tree. That's a kind of a tall tree. It's a dead tree too. Oh, it's, yeah, let's just like scale that down a little bit. And then let's like move it. What an awful looking tree. All right, let's, oh, I don't have any prefabs. Wind zone. Bro, what the 3D text. Hello? Oh, it says hello world, of course. Of course. Nice optimized tree, actually. Now I'm in the tree dimension. Okay. No, let's keep going. How we view the scene. Control zoom mode. Control zoom mode. Okay. Oh, I see. Mouse right button WASD. Oh, that would have been very helpful to. That would have been very helpful to know about earlier. Alt right mouse button. That is much easier. That is much easier. Cursor keys walking mode? It's literally the same thing. What is QE? Oh, that's like pan up and down. I'm like pressing shift because it's like Minecraft. But no. And I'm pressing space because it's like Minecraft, but no. No siree. Alt orbital mode. Yup. And okay. Sure. And experiment with the possibilities of the hand tool. Gang gang, gang gang. Alright. Let's get that light. Let's rotate that light. It doesn't do anything. Oh my. I'm a little bit afraid. Okay, so if I do this... Oh, there's nothing for the light to reflect off of. Okay. Even if I like go straight up in its face, it doesn't, it still doesn't show the light. Wow. That's interesting. Okay. That is interesting. Oh my, I see the sun. Wait, the sun. The sun is in Unity. Confirmed? The sun in Unity? Confirmed? Yeah, I can make it rotate at like different... I get it. Okay. So it's like... It's not like a light. It's like the sun. You can control the sun. It's under. I get it. I understand. I understand. Okay, let's make it high noon. High noon. Boom. Buddy, it's high noon. Okay, boom. If I go through this, nothing happens. Okay, if I go through it at an angle, it's as you'd expect. It's just like Minecraft. Alright. Cool, good enough. Snapping. Got it. It's fine, vertex snapping. Alright, beautiful. What the heck was that? What the heck? Okay. Okay, scene view, which is well, it's just this. Visible as buttons on the top of the view, they are not required at the beginning when learning Unity, but we briefly describe the most important ones. Okay. Hidden objects, skybox, fog, scene lighting. Oh. Wait, so if I rotate this up now, then it's always gonna be light. And if I move the sun, oh, the camera's over there, I see. So if I go down here and I rotate this, then it's not gonna do the, what? Oh. Just kidding, if I do this, then it will still be light. Got it. Okay. Okay, interesting. And shaders. Other advanced options. Is it just these? Alright, fair enough. First menu allows us to establish how we want to see the objects in the scene view. The most important ones are shaded wireframe and shaded wireframe. Okay. Sure. All right. The others are quite advanced. Render paths. The alpha channel. The areas with more graphic load and MIP maps that can give us information about the right size of the texture for the different objects. Okay, this is not a grammatically correct sentence, but who cares? Green with deferred lighting, yellow for forward rendering, and red for vertex lit. Okay. Okay, there's... Never mind. Alright, whatever. The alpha channel, the areas with more graphic load. Ah, I see. Alpha channel, what is this? Okay. Not sure what it means, but alright. MIP maps. Okay, sure. Blue, that texture should be bigger. The 2D button allows us to change the scene view to 2D or 3D mode. Okay. And the next icon allows us to see the light with the actual collection of light or with an ambient light? Oh, sure. The audio icon allows us to reproduce or not. Okay, sure. The next button allows us to show hide in the scene elements such as skybox, fog. There's an animated materials. Gizmos allow us to establish properties of the different gizmos. Okay. And this here. Okay. Um, Finally, a search control. Okay, a search function for finding specific elements in the scene. All right, hierarchy view.
Well, we have seen that the scene view is a very important view that allows us to do a lot of things when creating scenes. Now we are
Sure.
going to see another very important view. It is the hierarchy view. And the hierarchy view is going to complement some of the things we are going to do with our scenes. So first of all, what we are going to do now is to create again a wall. So we are going to introduce a cube. And now what I'm going to do is using Control D or Command D Mac, what I'm going to do is to create some duplicates. And again, remember, by pressing Control or Command in Mac, we can use the snapping tools in order to move, in this case by default 1 meter. Okay, so in this way, we can create in a very easy way something like this.
Uh-huh.
Okay.
He did it.
Able to create. So as you can see, with a bit of practice,
He did it before, whatever.
it is really possible to create complex things in a very well and comfortable way. Okay. So now, what we are going to do, as you can see, well, we have in this hierarchy view a collection of in a very well and comfortable way. Okay. So now,
What the
what we are
heck?
going to do, as you can see, well, we have in this hierarchy view a collection of cubes. What we are going to do is to create another game object, and this game object is going to be an empty game object.
I could literally edit this to cut out all the stuff that he repeats.
The empty game objects, as
And
you're
it
going
would
to
be
see,
better.
are very useful sometimes. Okay, let's see what an empty game object is. Well, we can create it using the right button. You see, you can create an empty game object here, or also from the game object menu, you have create empty. Okay, so the very first thing I'm going to do is to change the name, to rename it. So I'm going to click it, and then going to use, for example, wall. Okay, because this is what we have done, a wall, more or less. Okay, so imagine that the cubes are some kind of bricks. So now what I'm going to do in the hierarchy view is something.
Got it. All right. Sure. So if I make a new cube. Let's see if I can guess what he's gonna do. Okay. So Control D. Then I do this. I don't really know if I need to make a full. Okay. Whatever. I'll just do what he did before. Cube 1 is over here, so if I control, no. Can I not like shift click this stuff? Okay, an empty game object. And that does nothing. Why? Okay, so why is this? Okay, that's why. Alright, it just looks weird because there's like nothing for my brain to reference. And then I'm guessing he's gonna do something like this. Wow.
Very important in Unity. We can create in the hierarchy view what we call parent-child relationships, okay? And this is going to be very useful for many, many things. One example is the one we are going to do right now, okay? So I'm going to select the different cubes. We can select the elements in the hierarchy view as we select files in the Finder or in the Explorer in Windows. So we can use Shift, okay, in order to select a collection.
Okay. I don't know why I didn't do that. Wait. I'm dumb. I'm so dumb. I knew that, man.
Of, in this case, a collection of cubes.
Whatever.
We can use also Control Command in Mac in order to select individual elements, okay? So we can select, in this case, the 8 cubes. And by dragging and dropping, what I'm going to do is to, as you can see, this multiple selection, I'm going to drag and drop over the wall. You see? So in this way...
Oh yeah. Heck yeah, bro. Wall. Augers.
As you can see, we have now an arrow. The wall is the parent of all these cubes. The cubes are the children of the wall. So
Yep.
one advantage of this is, well, we can have the hierarchy view much more clean. This is a very interesting consequence. But another important thing is that now, if I select the wall, I can move all, as you can see, all the cubes, all together, okay? So any transformation I do to the wall, I'm going to do it to all, in this case, our bricks, okay? This is going to be very useful when editing very complex scenes. So our bricks, okay? This is our bricks, okay? Our bricks, okay? Our bricks, okay? Our bricks, okay?
Our bricks. You dumb.
Okay, this is
Transcript.
going to be very useful when editing
Whatever.
very complex scenes, okay? This is one of the consequences. I can still, of course, select, okay, any of these elements, and I can modify individually any of these elements, okay? So I have now these two possibilities. So to get access to the different elements, as you can see, I can select them in the scene view or in the hierarchy view, or I can get access to all the wall, okay? So empty game objects are very useful, as you can see, because they
Okay.
allow us to group collection of game objects.
Sure.
Remember that
Are we
can
gonna like
focus
do like are we gonna make a game right now
on
or
one element,
are we just navigating the program or the editor?
okay, using in the scene view the key F, okay? But another possibility in the hierarchy view is by double clicking, okay? If you see, by double clicking, I'm focusing on this element, okay, in the scene view. Okay, this is one of the possibilities of the parent-child relationships we can create in the hierarchy view, but this is not the only one, okay? So what I'm going to do is to start over. So I'm going to delete everything, okay? And we are going to see another possibility of this parent-child relationship. So in order to do that, I'm going to create a new cube, okay? And I'm going to add another one, okay? Another one. So I'm going to move it, for example, like this, okay? What I'm going to do now is to select the second cube I have created, and by dragging and dropping, I'm going to make it child of the first one, okay? So now, this is the parent, this is the child, okay? So this means that if I select, of course, the child, I can transform it without problems, but as we are going to see, if I select now the parent, every action I carry out on the parent is going to take an effect, of course, in the child. Another important consequence, if you see this cube, this second cube, pay attention to the transform. If you see the values of the transform, I'm going to undo this parent-child relationship, and you are going to see the difference. Undoing is very simple. I drag and drop outside. So now again, cube is not a child of the first cube. So pay attention to the components, okay? To the value of the position. If I drag and drop again, you can see that there's a change, okay, in the value, okay, of this position. The point here is that now the cube, the coordinates of this cube are not absolute. The coordinates of this cube are not related with the global coordinate system, but to the parent, okay? So the position now is relative to the parent. So this means that if I change, let's do that. If I change, it's important now to select pivot. If I change the position of the parent, I'm changing also the position of the child. If I rotate the parent, I'm also rotating the child. We can do that much more general. Okay, let's create another cube. Okay, and again, I'm going to move it. Okay, I'm going to move it like this. And I'm going to make this new cube child of this one. So now we have a 3-level hierarchy. So this is the grandchild of the first one. Okay, so again, if I select this, I can rotate, of course, the child and the grandchild. If I select now this one, I can rotate, of course, this one and the child. So this is very useful and very common in Unity. Imagine, for example, that you want to model a solar system where you have the sun, you have the earth, and you have the moon. The earth has to be rotating around the sun, and the moon has to be rotating around the earth. If you want to model these transformations using math, you're going to see that it is really challenging. However, if you use this parent-child relationship, the things becomes much more easy. So this is the main tools we have in the hierarchy view. As you can see, it complements a lot what we can do in the scene view. Of the first cube.
Okay, let me see what he did with the third one.
This position. I change, select pivot if the child. We can do that, think much more general. The parent, I'm changing also the position of the child. If I rotate the parent, I'm also rotating the child. We can do that, think much more general. Okay, let's create another cube. Okay, and again, I'm going to move it. Okay, I'm going to move it like this. And I'm going to make this new cube child of this one. So now we have a 3-level hierarchy.
Child.
So this is
child.
the grandchild of the first one. Okay.
Child.
So again, if I select this, I can rotate, of course, the child and the grandchild. If I select now this one, I can rotate, of course, this one and the child. So this is very useful and very common in Unity. Imagine, for example, that you want to model a solar system.
Okay, great. He didn't actually do what I thought he did. Is there nothing down here? Great. Nothing that I care about, really. Game view. The object is to show what your game will look like when playing. Oh, the objective is to show what your game will look like when playing. Using the scene cameras. At least... Okay, we have to have at least one camera. Got it. With these buttons, we can run, pause, or execute our game step by step. It's important that Unity allows us to change things while we are running the game in the editor, but most of these changes will be undone when we stop running the game in the game view. Okay. Where's my camera? Okay, my camera's over here. And it's in this direction. Got it. Okay. So if I play this, I'll have my epic new game. I call it blocks. Okay, and how do I like get out of that? Okay, I don't know the hotkey. Great. It's important in capital letters. Great. It can also be dangerous when carrying out steps we want to be permanent. Okay. In game view, we can change the aspect ratio and resolution of the final game. Maximize the game view when running and show some statistics about the game when running. Okay. Experimenting with different aspect ratios, I'm assuming that's what he meant to say, can be interesting in order to see how our game will adapt to different devices and screens. Poggers. Exercises. In the asset store, it is not difficult to find the assets to build cities. Try to find one free of charge if you can. Try to create create your own city in a scene. Practice with snapping, blah, 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 blah. Okay. So asset store. Graded assignments are locked. Great. Okay, asset store. How do I go to the asset store? Okay. I don't think I need to do this, but you know what? Sure, I'll just, delete everything. Okay, except for, my directional light, because makes it look like a gosh dang hellscape. Alrighty, and now I'm gonna make a little cube neighborhood here, okay? I don't care about, uh, about getting assets. Okay, I guess that's just along the axis. You know what? Let me just go let me just make this go down to like somewhere real low. Okay. Then I'm gonna make this a road. Okay. Just kidding. I'm gonna make it actually. You know what? Yes. Yes, give me that road. If I can actually center this correctly, then I might actually do this. Might I actually make this look semi-good? Okay, beautiful. Well, my computer is having a grand old time over here. Okay, so how do I extrude in like one direction? Like, ah, okay, never mind. So let's just make this like as far as the eye can see here. How? Okay. Actually, I want this to come this way a little bit. And that's probably good enough. Okay. Let's see. Boom. Kinda crazy. I'm kinda nuts, bro. I am kinda nuts. I forget. Yeah, there you go. And then I'm just gonna copy this. Ahaha, you know? Just gonna copy this. Okay. Let's make that a little bit thicker. Actually, let's look at the camera here. And that's fine. Let's make this a little bit thicker. Okay, everything is white, so I can't exactly tell the difference. So if I make this angled, then that should give me a perspective there. Okay, this looks so bad. Alright, whatever, let's finish it up. Let's finish it up real quick, and then I don't have to keep doing it. Okay, and then we got, let's just make another basic cube here. And, okay. Perfect. And then we can actually, move this down here. And let's scale this up. So sometimes this like doesn't work, but I guess that's all right. And then scale it up. Okay, scale it this way. These are the worst houses you're ever gonna see. Okay, how do I actually like... Oh, oh, that's not what I meant to do. Can I like, make it bigger this way? Alrighty. This is a journey. This is a whole journey. I do gotta say, this is an entire journey. It's not even snapped on to the gosh dang thing. And then this is what we're gonna do. We're going to duplicate these. Duplicate this a bunch of times. And then we're gonna duplicate this. I really don't know if this is something... Oh, nice. And then we're gonna duplicate this. And I don't even... Oh, actually it didn't... It hasn't gone that far. Nice. Okay, cool. And then we're gonna shift. Okay, no. So we're gonna shift click that. Actually, Actually, I want to move this over here. This is an art piece. Okay. And then I'm just gonna copy this. And beautiful. Amazing. Wow. Actually doesn't look horrible. It actually doesn't look horrible. Hello? Life Alert, welcome. Welcome to the stream. I actually thought this would turn out very poorly. Do you remember me? Yes. Yes. Yes, I do. Maybe not very well, but I do. All right, what a beautiful, beautiful image. Okay, I'm gonna flex this to all my friends. I'm gonna title it. I'm gonna send it to them and say, I call it Cube World. Cube World, yeah. Definitely not ripping off the name of anything else. But alright, let's continue. I was the one that complimented your facial hair. Alright, I also remember you... Okay, I don't know. I don't know if I want to say it out loud, but... I don't know, it's not offensive. But I vaguely remember you... Okay, I don't want to... I don't want to say it. Even though I've said worse things, I don't really want to say it. You know, it's... I don't know, I'm not in the mood. I'm not in the mood to say it. For some reason... Yeah, I don't know. I don't know, it's like... I stream and I am like kind of careful about what I say, and then after a while I like start not giving a crap. And then I just say whatever comes to mind. It's kind of like a it's like a what is the word for it? It's like a warm-up kind of thing. I'm like not warmed up to say embarrassing things right now, I guess. All right.
Hello. In this video, we are going to introduce the most important concepts when we start working with Unity. Scenes, game objects.
Yeah, I'm doing this this course on like I'm doing this Unity course on edX. So it's from a university, or this guy's supposedly a professor at some university or college somewhere. I'm assuming it's in a Hispanic country or a Spanish-speaking country, which I guess is Hispanic, technically. But whatever. Let's just say his English is not the best. But I'm hoping this course will teach me what I need to know before I go on to the next tutorial or the next course. Yeah, I hope it'll teach me what I need to know. And I'm probably gonna watch many other courses besides this one, just because I want to absorb it all.
It's essential before doing anything with Unity.
You get it.
Game objects are the fundamental elements in Unity. and represents any of the elements we can
And there's
have in a
nothing
scene,
else
such as cameras,
on this
2D or 3D
page.
elements, particle systems, interface elements, lights, etc.
Okay, what did he look at, bro? What was he looking at?
These elements will be placed in what we call scenes. The scenes will help us to divide our game or applications in levels, or different interaction screens.
Oh, okay, I guess the teleprompter's over here. But he just wants to look at the camera, I guess? Whatever.
It's a fundamental tool when dividing our game in different parts. For
Okay,
example,
game
the first screen is
object,
generally a scene.
scenes.
Each level of our game is going to be a scene. The final screen, for example, of our game or application is going to be also a scene. Game objects will be created from assets.
Unless you have an overlay over the game screen.
Assets are resources of all kinds, 3D models, textures, sounds, etc., along with colors created in the Unity editor, materials, animations, etc. The game object will have what we call components. Based on what components we add to the game object, this will be able to do one thing or another. For example, our main character in the game will be a game object. Depending on what components we add to it, it will be able to detect collisions or to be under the control of the physics engine, for example.
Oh, we add to it. Okay.
So we don't have different types of components, but game objects with different collections of components. One of the most important components.
We don't have different types of components, but game objects with different collections of components.
That we can add to a game object is what we call a script. That will model the behavior of the game object during the evolution of the game. We will be using C#. A script is going to be a portion of code, it's going to be a class, where we will be able to program how we want to control the game object. So we can better understand these three concepts with this diagram. Our application, our game, is going to be divided into what we call scenes. In our scenes, we are going to add game objects, using, of course, the Unity editor. Cameras, lights, models, terrain. And of course, we will be adding components to these game objects. And depending on what components we add to the game objects, these game objects are going to do specific things. So now, you know the three most important elements in Unity: scenes, game objects, and components. We will be using them very soon.
All right, poggers. Scenes, game objects, and components. Creating a first example. Like, here's the thing. I just want to, like, when I make a character, or when I make it so that I can control my character with my mouse and keyboard, then I know we're getting started, baby.
Okay, let's create our first example in Unity. And what we are going to do is, of course, to go to New, and we are going to create a new project. I'm going to call it...
Oh, I didn't rename this. I didn't rename this project. I need to rename this to Learning Unity. Okay, well, I have to close this first. Save. And then Learning Unity. So, I'm actually wondering, okay, is it not gonna update? Okay. Okay, no, it bugged out. Can I not rename this? Add command line arguments. Brother, what the heck? Can I move this in here? Nope. Alright, I guess I'll just have to name it back. I'll just have to name it what it was before. Thanks, Unity. Gosh, hacking, dang it. What a great... Why can't I rename my crap? Come on. Okay. And then I'm gonna and I'm gonna boom. Nice. Okay, can I like can I like hide this? Please? Can I like stop? Array size. What in the world? Can I please hide this? Can I like make it invisible, please? Move to view. Camera. Oh, no. That's not what I want. Oh, I messed this up. I didn't have this. Didn't move outright. Whatever. It still turned out well. It gives that, you know, gives a little bit of depth. You know. I'm just freaking. I'm like trolling so hard. I have no idea what I'm doing. Can I just please hide this, please? Okay, so the properties are over here. Can I hide it, please? Can I make it invisible? Can I please make it invisible? No? No, I can't. Audio reverb zone. Audio reverb zone. Text Mesh Pro. Have your family said anything about your facial hair this time? Yes, they hate it. Well, most of my family hates it. Toggle active state. There you go, bro. So if I click this, does anything change over here? No? Okay. I hope that's like a... I hope that's a hotkey. Okay. What am I doing? Bang and bang and... Have you found a girl yet? Nope. Nope. I think I need to work on myself before I do that. But no. No, I have not. Obviously, you know, obviously if I find a girl that I like, I'll try to speed up the self-improvement process. But you know, I don't go out much. So
First example. This is the location where our project is going to be created.
So,
I'm
yeah.
going to create just a 3D example. It is very interesting to know that, as a matter of fact, what Unity is going to create is a folder with this name, with first example. So a new project is going to be a new folder. And inside this new folder, Unity at the same time is going to create a collection of subfolders in order to add the different elements we need for our application or game. So let's create this project. This takes a while sometimes. And what we are going to do now is to learn what are the main components of our project. So you are going to see that in our project, we are going to create some subfolders in order to add some of the elements we are going to need for our application or game.
I think it's good you're focusing on yourself first. Thanks. Thank
Using
you.
the Finder in Mac or using the Explorer in Windows.
I probably also need to get a stable job. Well, okay. Like my family always, or yeah, I mean people usually don't don't wait a long time to get married, or that's how it used to be. But you get it. You get it. I'm waiting, obviously.
We will be able to see which is the folder structure Unity generates, the Unity editor generates whenever we create a project. So it is going to be very interesting to see this structure in order to be able to understand how it works. If you want to save your project, don't forget that you have to save the whole folder, not just a collection of files, but the whole folder, that it is going to have the exact name of the project.
Okay, what did he say up here? And inside this new folder, Unity at the same time, collection of subfolders. Create this project takes a while sometimes. Okay, wait. We're gonna create subfolders in order to add some of the elements we're going to need. All right, whatever.
Okay, here we have Unity, okay, and as you can see in the top, sample scene is the default scene Unity creates when you create a new project, okay? And first example is the name of the project. So by default, Unity creates an initial scene it calls sample scene, okay? So in this sample scene, as you are going to see, Unity also creates, as we can see in the scene view, two elements. A main camera, and the camera is the eyes. The camera is the eyes of the player, and a directional light. The directional light is going to help us to be able to see something in our scene. As you can see, and this is also very important, in the project view.
Whoa, sick zoom. Sick zoom, bro.
We have the assets folder of our project. When we create a project, remember, Unity is going to create a folder with this name, and inside this folder, several other subfolders. One of them is very important, it's the assets folder. And inside the assets folder, by default, Unity is going to create another subfolder. It is called scenes, with this sample scene, our first scene, okay?
Okay, let's see that. Bam. Okay. It actually already made, when I added this tree, it made the tree? Or it like added the tree asset? And when I made the terrain, it added the terrain asset. Alright, interesting.
So we can create here any collection of folders. We can see that in the Finder in Mac or in the Explorer in Windows. So as you can see, we have created this, our first example project. And as you can see, Unity has created a collection of folders for the different elements that are required for our project.
Okay, I get it.
And one of the
Folders.
is the assets folder, okay? And by default, it has created also a scenes folder with this sample scene. Well, we can change the name of this sample scene, so we can rename it, okay? For example, first example, the same name of the project. So this is just an example. And inside this assets folder, we can create any new subfolder, okay? And it is going to be very common. We can create and we can import elements inside this assets folder. In the project view, in this assets folder, Unity is going to help us to import any collection of elements we want to use in our project. For example, 3D models, textures, sounds, etc. And also we will be able to
Sure.
create inside the Unity editor new elements we are going to use in our project. So using the right button, as you can see, we have create, where we can add new elements inside the assets folder.
Sure.
But it is very common, instead of creating all the elements in this assets folder directly, it is very common to create a collection of subfolders, as Unity has done with the creation of the scenes folder. So we can create, for example, another folder for our scripts. Okay. It is very common also to create another subfolder, okay, for our materials. The name of these subfolders are up to the developer, okay? So we can call these subfolders as we want, no problems at all. However, it is really common to use names such as materials, scenes, scripts, and so on. So this is one of the first things we are going to do whenever we create a new project in Unity. It is very common to create a collection of subfolders in order to import from other packages or to create new elements we are going to be using in our application or game. So the project view, remember, it's very important. It's a kind of visualizer of our assets subfolder, the subfolder of our project. And the first step normally in Unity is going to be to create a collection of folders in order to add elements we will be using in our game or application.
All right. So let's make materials and scripts. Is that all he did?
Our project and kind of scripts and folders.
He just created new
Unity
folders.
has done with the creation of the scenes folder. So we can create, for example, another folder for our scripts.
Ah. I see. Okay, he did just make a new folder for scripts, but I don't really know how. I don't really know if I need to do that right now. I guess this is just to show that they're empty, right? Probably.
Okay, let's work a bit in this first example. Remember that by default, Unity has added a couple of game objects to our scene. The main camera, which is a very important element. We need a camera in our scene because the camera is going to be the player's eyes. So what we see from the camera is what we are going to see in the game view, okay? So in the game view, we are going to see what it is in front of the camera. The other element is a directional light. A light is also generally necessary because without light, we cannot, of course, be able to see anything, okay? So what we are going to do in this first example is to have a kind of floor, and on top of this floor, we are going to put a sphere. This is going to be our main character, a sphere. And the objective is going to be to move this sphere using the keyboard or a gamepad, okay? This is the idea. So in order to do that, we can go to the Game Object menu, and in the 3D section, we have something called
Whoa, bro. What did he do?
So we
Okay. The first example is to have a kind of floor. And on top of this floor, we're going to put a sphere.
put one of these planes, and this is going to be our floor, okay? So I'm going to rotate the plane a bit. So the camera, as you can see, we are going to have the camera like this, okay? So this is going to be the normal position of our game. And as you can see in the transform component of the plane, we have some very arbitrary values for this plane. It is very common to start
for this plane,
as in 0, 0, 0, okay? So we can do it by changing these values manually, or we can go to this gear wheel we have here, you see, and we can reset, okay? With reset,
we can reset. I'm thinking he's Hispanic, not Italian, right? Not something like Italian. And then it doesn't matter where we put our light because it's just global directional lighting. Okay, plane. And why is this not already here? Okay, and then we make a sphere. Sphere, and then we reset that too. I don't know why it's not there. Okay, let me reset it again. I was doing the wrong thing. And then we drag our main camera to our sphere. That didn't work. Okay, that did not do what I wanted it to do. So we're gonna find out.
We put everything to
first.
0, the position and rotation, and the scale to 111. Okay, so I'm sure that the center of the plane is in 0, 0, 0. Something very interesting. Okay, so this is going to be our floor. Okay, so now we are going to put the main character, and the main character is going to be a sphere. So I go to the game object menu again, 3D object, sphere. So again, I'm going to reset the position of this sphere. So let's go closer. And as you can see, the center of the sphere is now on 0, 0, 0. Okay, so this means that, as you can see, half of the sphere is under the plane, half of the sphere is below the plane. So in order to correct that, I can, of course, using the translation tool, the move tool, we can move it manually, or knowing that the diameter of the sphere is 1 meter, what I can do is to go here and to put 0.5. Okay, so in this case, to use a numeric value is going to be much more convenient. Okay, so as you can see, now we have the sphere that it is exactly on top of the plane. Okay, and here we have our camera.
Poggers, sphere,
so let's
poggers.
see what we see from the game view. Okay, this
poggers,
is what the player is going to see when we run
sphere.
our application. So if we run our application, okay, this is what the user is going to see. If you want to change this vision, okay, we can go to the scene view, we can select the main camera, and we can manipulate the main camera. With the move tool, we can make the camera to go closer. Okay, we can even rotate the camera. Okay, like this. Okay, you see, we can move it. So here in the camera preview, you are going to see that we are changing what we are going to have in the game view. Okay, so
okay, I guess I'll probably learn about camera manipulation later. But like this, like what if you don't want this to be the view of the camera? Like, I'm assuming you'll be able to like constrict the view or expand the view. I guess that would just be FOV, right? But I don't know where that is. It doesn't really matter right now.
This is one possibility to change.
I'm very new,
the position
of
and orientation
course.
of the camera, okay, manually or using the transform component. Okay, this is one possibility. Another possibility that it is also very useful is to try to find a very nice view of the scene in the game view. Okay, this is what I'm going to do. Okay, so using the different tools we already know, we can have something like this. So imagine that you like this. Okay, you like this point of view, which is
imagine that I like it. All right.
So now what we can do is to copy this point of view into the main camera. So we select the main camera, we go to game object, and we say align with view. This means that this view is going to be copied into the camera. So the camera is going to be transformed in order to get something similar to what we are seeing right now in the scene view. Okay, we do it. Okay, so this is, as you can see, more or less, okay, what we have. We have changed the game view, okay, with a similar view that we have in the scene view.
Okay.
So this is our first steps. Okay, so now we have the floor, okay, this plane. Now we have the main character, which is the sphere. Now in the next videos, we are going to try to add some more properties to these elements. And of course, the final objective is going to be able to move this sphere in a very interactive way.
Why? But why did
to copy this point of view
you do
into
that?
the main camera? So we select the main camera, we go to game object, and we say align with view. This means that this view is going to be copied into the camera. So the camera.
Okay, does the camera not have a dynamic view? I thought it did. Align with view? What? I'm so confused. I'm so confused. Alright, and then I align with view. Does it not just automatically, like, Does the camera not just automatically do that? Like, seriously, what? Alright. Whatever, I guess I'll find out. Find out what it is later.
Okay, so following this, our first example, we are going now to create something very important in Unity. We call them materials. Materials are very important because they are going to indicate to Unity how we want to draw, how we want to render the different game objects in our game or application. So this is what we are going to do now. So remember that we created a collection of subfolders. In this case, we created one called materials. Remember that the name of these subfolders is up to you. So it is not really necessary to call it materials if you don't want, but it is very common, of course. So we go inside these subfolders, materials, and with the right button, we go to create, and we have the option of creating.
You know, what's so funny is he's like emphasizing the fact that, oh, we can name the folders whatever we want, just in case someone is like, you have to name it materials. You have to. It's like, okay, it's just funny that he's emphasizing that.
Material. We are going to put a name to it. In this case, we are going to put plane because this is going to be a material I'm going to use in the plane, so it's quite a quite convenient name.
Sure. I don't actually remember what he did there. He just did material. Alright. Plane. Sure. And then what do? I drag it to the plane. Okay. Whatever, let's just continue.
Unity is going to create something new.
You know, usually with these things, it's like, usually with coding tutorials, I mean, this obviously isn't the same. I can like guess what they're going to do if they, like if they've already taught me what to do, but I guess if they, I guess I just haven't learned what to do yet, so I don't know why I'm trying to do anything.
.mat, where we are going to store the properties of the material. The materials in Unity are defined with something we call shaders. Shaders are something very complex, and they are like little programs that are going to indicate how we want to draw the object. And this is something very, very complex. However, we have a long list of possible shaders we can use inside Unity, already prepared for us, okay? So by default, we are going to use a shader. It is called the standard shader. And in the inspector, you can see that you can indicate a lot of properties for this standard shader, okay? So we can use any of the list of shaders we have here, and it is even possible to create our own shaders, but this is a very complex topic, okay? Right now, the only thing we are going to do is to use the standard shader. It is very flexible, very powerful. And in this case, the only thing we are going to change is something that is called the albedo. In the albedo, we can indicate.
What does albedo mean? Wait, what does albedo mean? Why are there so many characters called albedo? What does albedo mean? Is the measure of the diffuse reflection of solar radiation out of the total solar radiation and measured on a scale from 0 corresponding to a black body that absorbs all incident radiation to 1. Measure of the diffuse reflection of solar radiation out of the total solar radiation. So light, they just mean light. Right? It's just like reflectiveness. It just means reflectiveness, right? Why are so many characters named albedo? Okay, I don't give a crap about Overlord. Can you please? Nope. Alright. I guess it's just because it's like cool
a
sounding,
texture or a color in order to
right?
paint to render our object. Okay, so the albedo is going to be the color of our object. We can indicate a texture or we can indicate a color. Right now, the only thing we are going to do is to indicate just a color. So we go here, we click, and for the plane, we are going to select, for example, a green color. Okay, so a green color, something like this. Okay. So now we have the first material, the material we're going to use for the plane, but now we're going to create another one, another material. In this case, I'm going to call it, for example, the sphere. And I'm going to do exactly the same thing. I'm going to go here and I'm going to indicate a red color, for example. So you can create a collection of materials and without limit, with a lot of properties. But as you can see, in the scene,
without limits? Wait, no limit? That means I can create an infinite amount of materials?
And this is because we have to assign somehow the materials I have
not even limited by my storage space?
created with the elements
Yeah,
we have
never
in the
mind.
scene. And we can do that in very different ways, but probably the most easier way is to just drag and drop. Okay, so we can select the plane, the color, the material, and we can drag and drop it over the plane. And this is something we can do also using the sphere. Okay, so we can do that in the scene view or in the hierarchy view. Okay, so right now, as you can see, we have created a couple of materials and we have assigned these materials to our game elements. Okay, so if I select one of them, for example, the sphere, you can see that in this area, it is called materials, we have the material sphere. Okay, this comes into something it is called mesh renderer. This component is going to explain to Unity how we want to render, how we want to draw our elements. Okay, and this is something that has happened automatically by dragging and dropping. Okay, of course we can also drag and drop in this field we have here. Okay, so this is going to have the same effect. So right now, as you can see, we have these two materials, we have these two elements, and we have indicated with that how we want to draw, how we want to visualize our two elements. Okay, so right now the only thing we have to do now is to animate the sphere, and we are going to animate the sphere following the user's interaction, and this is what we are going to learn right now.
Okay, poggers. We're actually gonna start doing things. Sphere. Okay, let's make this some kind of dark green. Poggers. That's not dark green. Whatever, let's make this orange, because I like orange. And bang! Wow. Very crazy. Oh, baby dude, creating the script. He's just gonna tell me to do this, right? He's just gonna do that. He's just gonna tell me to do this. Crazy, bro.
Let's undertake one of the most interesting tasks in Unity. We are going to model the behavior of our character, in this case the sphere. And we do it with a component we call a script. A script is just a fragment of code we can assign to any game object. Its mission is to model the behavior of our character, depending on the user's interaction, or if we are talking about enemies, depending on some rules. In order to do that, we are going to go to the scripts folder, okay, in the project view, and using the right button, we are going to create a C# script.
Nuts.
We can use any name. In this case, we are going to use move, okay? As you can see in Inspector, we already have a template for this script. So as you can see, move is going to be a class. The script is in C#. C# is a programming language which is not difficult to learn if you come from Java or C++. So as you can see, it's a class, and by default, we are going to have a couple of methods, methods that we are going to better understand in the future, okay? So what we are going to do now is to open this script and to edit this script. And we do that using an external tool. We don't use the Unity editor.
Hi, bro.
As a matter of
There's
fact,
like
if we go to preferences,
my eye
in
is like
external tools,
dusty or dry
you
or
can see
something.
that we can select a specific editor for editing our scripts. So by default, we have Visual Studio.
Okay,
What we're going to do
preferences.
now is to open this script and to edit this script. And we do that using an external tool. We don't use the Unity editor. As a matter of fact, if we go to preferences, in external tools, you can see that we can select a specific editor for editing our scripts. So So by default, we have Visual Studio, but we can use other editors. And as a matter of fact, there are many possibilities right now in order to edit the scripts in Unity. But we are going to use the default one. So now, if we double click into Move, here we have the Visual Studio, and we have here the first template for our script. So remember, the script is going to be very important. It's just another component of our game objects. And in the script, the mission of the script is going to be to model the behavior of our character, in this case, the sphere. As you can see, the script is just a class that derives from MonoBehavior. And we have two main methods we are invited to write. The method start, that it is going to be called whenever we run the application, and the method update, that it is going to be called every frame. But this is something we are going to explain better in future videos. So this is what we are going to do in the next videos. We are going to provide much more information.
Bro, I hate Mac so much. I hate iOS.
Inside the update, in order to get the interaction of the user, and depending on this interaction, to move the sphere. But this is something we are going to see in the next video.
All right. Cool. Let's get it. I don't think I'm signed into Visual Studio on this computer. So let's just see what happens. And my computer is crapping itself. Do I even need to sign in? No, I don't. Thank God. Okay, I hate it already. Oh, I am signed in. Okay. I don't really want to show that, but it's too late already. Has gone stale. Your license has gone stale and must be updated. Okay. An error has occurred and we can no longer retrieve user information. Please re-enter your credentials. Okay, I will re-enter my credentials. I think that's the right password. It is not. I think I have to... I don't remember when I changed this, but... let me just put all my passwords in. And see which one works. Do I actually have to update my license? Oh, no, I just had to click it to update it because it's free. Got it. Thank you. Thank you, Microsoft. All right. Now we're just hacking, do it. We're just hacking, keep learning. Okay, poggers.
Okay, so let's put some code in the update section, in the update method, in order to make our sphere move depending on the user's interaction. In this case, we are interested in the left and right keys of the cursor. But what we are going to do, it is going also to work if we have a joystick or we have a gamepad. In order to do that, we are going to put something here in the update. The update is a method that it is going to be called every frame. A frame is every time the screen of our device is going to be updated.
Like static void. Okay, so I guess it's just those three, right? For a method, public static void, but it could also be private and it could also be not, it could also not have static and it could also return something else besides void. But I guess every for every method that is doing something in a script, then I guess it will just um it'll return void every single time, I guess. Sure.
This happens quite often, many times per second generally, okay? So inside the update, we have the opportunity to put some code in order to change the behavior of our character during the execution of our game, and of course taking into account the user's interaction.
Okay, also, uh, yeah, during every called once per frame. Oh, once per frame. Okay, so that's really fast. I guess people usually go by time on the computer, but I'll figure it out.
We are going to do that by accessing to transform. So remember that transform is a component of the game object where we have position, scale, and rotation. What we want to do is to change the position of the sphere. So we can get access to the position using the component transform, where the position is. If we press the dot, you can see that we have many methods we can use in order to do things with transform. And in this case, we are interested in translate. Translate is going to change the position by adding something, a displacement, okay, in any of the three axes, okay?
So we need an
If
if.
we open the parentheses,
St
as you can
oh.
see, we have 6 possibilities in order
No.
to put the parameters of the translate. So we have several possibilities. In our case, we are going to use this one, okay? So we are going to indicate how much displacement we want in the X, Y, and Z axis. In this case, I'm going to move the sphere only left and right. So we are going to put something only in the X element, in the X component. And in order to do that, I'm going to consult the user interaction. And in order to do that, Unity has a very powerful tool. It's the class input. Well, as a matter of fact, it's an object. So in the object input, we can get inside the update.
Oh, it's a class input. Actually, it's an object. Bro, what the f?
What is going to happen? What is happening with the different
They're the same. They're like the same thing.
In this case, I'm going to use a method. It is called getAccess. And in particular, I'm going to consult a very specific axis. It is called
Almost,
horizontal.
I guess, whatever.
So in this horizontal axis, what we are going to consult is the left and right keys of the cursor keys, or we can also consult using this getAccess horizontal left and right of joysticks and gamepads, okay? And what this input getAccess horizontal is going to return is something from -1 to 1, depending if we are typing left or right, pressing left or right, or using a joystick left and right. We have from -1 to +1 because we can use an analogical joystick or gamepad, okay? So this is what we are going to have in the X-axis. But we are not going to do anything. We don't want to translate anything in the Y or Z-axis. So this is going to be our first instruction.
Oh.
Inside this script.
Okay, sure.
Transform translate, where we consult the interaction of the user in order to move the sphere in the X-axis. And the amount of movement we are going to have is from -1 to 1, so -1 meter to 1 meter, depending if we are pressing the left or right keys of the cursor.
Right, this is gonna be so jarring. This is gonna be so jarring, bro. I hate Visual Studio. Wow. Oh my gosh, I hate this. I really dislike this. Which one is it? Okay, can I remember it? Position. Get axis. Okay. Get axis. Where is that? Oh, get axis. Oh, it shows the Unity things, I'm guessing. Oh, these are methods. Okay, these are methods. Sure. Is it... Okay, it's capital G, but it doesn't matter because I can just do that. And then horizontal. And is that just gonna do its own thing? And then I put that, and that should be good.
Or if we are using a gamepad, if we are pressing the left and right buttons. Don't forget to save the script, okay? Using Control S or Command
Sure, Control S.
S in Mac. Don't forget to store this moment the current version of this script. So we can minimize.
Oh, that's a lot of subs actually.
Go back to Unity, and the step we are going to do now is very important. Right now we have the script, but we have to assign this script to the character. Remember that the script is just one component more, so we have to assign this script, this component, to the game object, to the spheres. And we can do that again by dragging and dropping, okay? So if we select now the sphere, you have to be sure that we have the move script as a new.
Okay. Okay. Sure, load that. Bang. Okay, I don't know why it didn't just... That is so dumb. Okay, now we click it. Now it has move. Now we do play. And this is gonna be... What? What the heck, bro? I wanted to go right 1 meter, bro. Where the heck? What? Bro, 1 meter. What? Oh, it's once per frame. What am I doing? Bro. So if I just tap it? Okay, that was like 2 or 3 frames. Got him. Got him. Wow, that's so poggers. Oh, and since there's no physics, I can just like do this all I want without it like this is so silly looking. What the fudge? Wow, 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 wow. You know what? Let me do this. I'm assuming it's vertical. Oh, X, Y. Oh, this is Y. Yeah, Y. Oh, whoopsie. I'm assuming that's correct. Right? Is it? No overload for method get axis takes 2 arguments. I don't care. Okay. Now let's start it again. Fudge. But why? Okay, I'm going too fast. I just want to see my sphere fly. Come on. Lame. That's lame, bro. Freaking lame. Oh, fudge, is my Unity crashing? Can I please, like... Can I please go to my console, thanks? Or my project view? Ging, 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 ging. I'm actually surprised that it doesn't, like... Oh, okay, never mind. The frames are there, it's just, like, happening so many times. Like, it does it... Since it does it per frame, it's, like, somewhat smooth. instead of just like teleporting. Got it. All right. All right. I get it.
New component, okay? And be sure that you have only one copy, okay? Because we can assign, as you are going to see, many scripts to our game object. And sometimes by mistake, we can assign more
Oh.
than one instance to the game object, and this is not going to be convenient, okay? So be sure that we have one copy of our script here as a component.
We can assign more than one instance to the game object, and this is not going to be convenient? What the fudge do you mean it's not going to be convenient?
Component of the sphere. And now it's just a question of trying to see how it works. So we go to run. So we have here the game view.
Okay.
And now use the left and right keys, as you can see, and we can move, okay, 1 meter per frame, okay, our sphere left and right, okay, using the cursor keys. If we have a gamepad, the consequence, or a joystick, the consequence is going to be exactly the same. Okay, so we have accomplished our first objective. We are now able to move our sphere left and right, okay, depending on the interaction of the user. So we can stop, and now it's time to do something else.
Okay, leaving me on a cliffhanger, bro. Not cool. Not cool.
In the previous video, we have seen that we are now able to move our sphere left and right. So if we run, we see that we can move the sphere left or right using, in this case, the cursor keys, okay? And that was thanks to the creation of a script we called move. So this is the script we are using right now. The important thing here is that in the x-axis, we are moving a magnitude that depends on the cursor keys. And this magnitude goes from -1 to +1. So this means that we are moving up to 1 meter per frame. What happens if we want to change this? Well, if we want to change this, one possibility is to multiply, for example, this magnitude by 2. This means that we will be able to move 2 meters per frame. So we can multiply, for example, 0.5. In this case, we have to put the suffix f in order to change it to float instead of double. So this means that we can move now half meter per frame. What happens if we want to be able to change this magnitude? Okay, well, one possibility.
Change it to float instead of double. What would a double be? Double Java. Great. Someone just... What? Oh, never mind. You don't have access to that crap. Okay, you do have access to this. But whatever. Floating point numbers. Double and float Java. Oh, I see. This is higher for some reason. Okay, all primitive. What the f? Sure. Primitive types in Java. Oh, sorry. Not Java. And C#. C hashtag. No, and C#. Bool, byte. Okay, a byte is like nothing. Byte is 0 to 255. Oh, okay. A byte is 8 bits. Char is how many bits? 16. All right. The decimal is okay. The decimal is 16. Actually, it's more than float and double. All right. Nint. Nuint. Nint and Nuint keywords To define native-sized integers. Interop scenarios. Low-level libraries. And to optimize performance in scenarios where integer math is used extensively. System.inputr. Okay, that's different. Whatever.
Is instead of multiplying by a fixed quantity is to use a variable, for example, speed. But of course, we have to define this speed somewhere. If you are familiar with object-oriented programming, you know that you can do that here as an attribute. This is what we are going to do. We are going to define speed as a float, okay? Well, now we have the possibility to initialize speed here. We can initialize speed. We can use, for example, 2 or something like that. This is very common. Please
define it, gosh.
But in Unity, we can leave speed without an initial value, okay? So we can just define speed there. So this is what we are going to do. I'm going to save this script. Remember, Control S or Command S in Mac. And now I'm going to go back to Unity.
Okay.
If I select sphere, we can see in this sphere that we have the script move. And if we pay attention, you see, we have now in the script speed with the initial value of 0. So this is very interesting. This means that whenever you put something, an attribute, public, in a script, this attribute is going to become visible in the editor. This is very interesting because this means that we can initialize this value from the editor directly without having to go to the code editor. So this is something we are going to do very often. For example, we are going to put 0.5 right now. So instead of using constructors are not going to be a very good idea to put. So
why does it capitalize the first letter?
Public, they are going to be visible from the editor.
Just
so we can initialize these values
directly for fun, I guess.
Okay, so this is the value speed is going to have when we run. Okay, so it's a kind of initializer. So now if we run, now we can see that we are moving half meter per frame. You see? So very interesting. Okay, so remember, if you want to do something more general, like this example, you can define an attribute, you can define it as public, and then inside the Unity editor, you can initialize this value. This is something we do very often because it allows us to experiment with different values inside the editor without having to modify our code. But now we have a problem. The problem is that the movement of this sphere is, in this case, 0.5 meters per frame. And this means that the speed of this sphere depends on the frame rate.
Okay.
And the frame rate depends on machines. We can have different frame rates depending on the machine, on the device. Even in the same device, the frame rate is not constant. So this means that the movement, the speed of this sphere can be very variable. And we have to correct that. We are going to see very soon how we can do this.
I honestly don't know why it's not based on the clock or based on whatever. I don't know what we base it on. Like, I don't know why it's not based on this by default. Like, why is it based on frame rate by default?
When animating a character in a game or an interactive...
Okay. Ugh. Sure. And that just changes. Let me just see. Click this. Okay. If I click this, then it's speed. Got it. So if I play this, it won't move at all. Or is that just counted as undefined? Bro, look at this. Can I... Wait, can I do this? Wait. Okay, can I do this while it's running? I think no, but yeah, it doesn't stay. So 0.00. So if I do 0, then it shouldn't move. What? Is it just not gonna, like, if I have it as 0, it's just not gonna move? Or it's just gonna not count it as, like, defined? That's weird. Is this actually, like, 0.1? Really? Oh, I didn't do this. Ooh. I didn't do that. God bless. God bless, bro. So if I do 0, then it's not gonna move. Yeah, alright. I do 0.01. Okay, sorry, whoops. 0.01 here. Let's see how slow that is. It's actually quite fast. Never mind. 2.001? Yeah, buddy, that's my speed. That is my speed. Okay. Pretty good.
Application, we have basically two possibilities. We can have what we call a kinematic approach or a physics approach. A kinematic approach means that we, as developers, we are going to control the amount of change we want for our character in every frame. So using methods such as translate, scale, or rotate, we are going to specify the amount of change we want every frame. So this means that we as programmers, we are under the control of the movement of the character.
His handwriting is very good, I do have to say.
This is, for example, what it has been done.
I guess if he speaks Spanish, then. Wait, this is. I think it's Spanish. Yeah, then it's like almost the same alphabet. So never mind.
In arcade games, traditional arcade games such as Pac-Man or Galaxian. But we have another possibility. The other possibility is that the movement of the character is the result of the application of a collection of forces using the physics engine. So this means that we as developers, maybe we are going to specify some forces. We are going to have other forces such as the gravity, and the movement of the character is going to be the result of these forces. But this movement is going to be controlled by the physics engine, not by the developer directly. We are going to pay attention to the kinematic approach now. In the kinematic approach, this means that we want to move our character and we want to control this by code. So normally we are going to do that inside the update method. So inside the update method, remember we can get access to the transform of the object, and there, for example, we can carry out a translate where we can specify a displacement, an amount of
DX DY. Oh my gosh, bro. What in the world? This guy's like a fudging physicist or something.
change we want to carry out to our character. As you know, these magnitudes in Unity are meters. The thing here is that we have to understand something very important. It's the concept of frames per second. We have to understand this because these meters, this displacement, is going to be carried out every frame. So frames per second is going to be very important. Frames per second is the number of updates our device is going to do to the screen depending on many factors. So we can have different values of frames per second depending on, well, basically the device. So it's not the same to have a mobile device or to have a console or a desktop machine. So the performance of the device is going to be important. So the number of frames per second we are going to have is going to be, of course, a function of the performance of the device. But even in the same device, these frames per second can vary. So we can have, for example, from 60 to 20 frames per second, depending on the load of the scene. How many elements we have in the scene in a specific moment, the geometry of the elements we have in the scene in a specific moment, depending on the scripts that are in execution in a specific moment. So this means that this magnitude, these meters, we are applying in the translate, this change is going to be dependent on the number of frames, and consequently depending on the device and depending on the load of the scene in a specific moment. So we have something called meters per frame in this case. So these meters we are applying inside the translate are meters per frame. So this means that we have a non-constant movement or speed. And of course, this is device dependent. And this is a problem. This is a problem because we want to be able to move from a point A to a point B. We want to move our object with the same speed, no matter the device, no matter the moment we are in the scene, how much elements we have, how many elements we have in the scene. We don't want to depend on the scene load. So we want to be sure that our character is going to go from the point A to the point B in the same time, no matter the device. Well, in order to do that, let's imagine that we want 1 meter per second. If we want 1 meter per second, and imagine that we have a machine that is running at 60 frames per second, how much movement I have to apply in the translate inside the update? Well, it's very clear. 1 divided 60. If I apply this amount of movement, after 60 frames, I will be moving 1 meter. So this means that if I want to move 1 meter per second, the magnitude I have to put inside the translate is this one. So I have to take the magnitude, okay, 1 in this case, and to divide by the frames per second. So if I divide the magnitude by the frames per second, I'm transforming from meters per frame into meters per second.
Ah.
We have something it is called time dot delta time. Time delta time is not the frame rate, it's the time from the last frame. So if you think a bit, this is the same of 1 divided the frames per second, because the time from the last frame in our example is 1 divided 60. So in our case is 1 divided by 60. So if we want to transform 1 meter per second into 1 meter per second, the only thing I have to do is to multiply by time delta time, which is the same of divided by the frames per second. So for example, if we want to move 3 meters per second, what we have to do in our update is, in the translate, 3 multiply it by time dot delta time, and whatever. So this means that by multiplying by time delta time, okay, what we are doing is dividing by the frames per second. So we are moving 3 meters per second. If we don't multiply by time delta time, what we are going to have is 3 meters per frame, which is a problem. This magnitude is not a problem because this means that I'm going to have always the same speed, no matter the frame rate, no matter the device. And the same thing if we want to rotate. If we want to rotate a specific quantity of degrees per second instead of per frame, we have, of course, to multiply by time delta time. Always multiply by time delta time. And the same with the scale. So whenever you want to carry out a kinematic approach in your game and you want to move with a constant speed, remember, you have to multiply by time delta time in order to transform this magnitude from magnitude per frame into magnitude per second.
Wow. I do remember seeing that on some Unity tutorial I watched a long time ago. But obviously, I forgot. But let's just get into it.
The concept of time delta time, what we are going to do now is to change our example in order to use this concept. So we go to the code, and remember, here we are applying
Nice. So I just do time dot delta time. Poggers, and then I don't even need this. Nice. Loggers, let's check it. Wow. That's quite slow. That is quite slow. And it kind of takes a while to, like, get started. I feel like there's a delay. Because time delta time only does time until the like, time from the last frame, right? So maybe it has to wait a frame? But I wouldn't really be able to tell that, but I kind of can. Maybe I would be able to tell that. Alright, well that's fine.
And magnitude, a translation that depends on the frame. So this magnitude is going to be applied every frame. And this is a problem, okay? Because you know that the frame rate is something that it is not constant, depends on the platform, and depends on the moment of the execution of the game. So we want our sphere to move in a constant speed, okay?
One frame's not a big delay.
It's enough to multiply by time, delta time. Every time we multiply by time delta time, we are transforming this magnitude from a magnitude per frame to a magnitude per second. So this means that now speed is velocity. Speed now is a magnitude per second, okay? So meters per second. So if we save and we go back, we select our sphere. So now this 0.5 are meters per second, half a meter per second. So now
Okay. So I'll just I'll just like add that. Just like add it back.
now if we run, we are going to see the difference. If we move, we can see.
Oh, this doesn't pick me whispering. Whoops. Pick up the mic. Or the noise gate doesn't pick up me whispering. Whoops.
We can see that more or less you can see the change in the transform, that we are changing about half meter per second. We can change this magnitude. Remember that if we change this magnitude now, okay, we have to click on the game view to be able to interact. Remember that the changes we do while we are running are not going to be persistent, okay? So we can now check which is the magnitude we like the most. So 4 meters per second, for example.
Okay, so that does work.
To get back the previous value. So we are going to put here, for example, 4, okay? So now this magnitude is meters per second. And this is going to be in every device, even with different frame rates.
Cool. Very cool. I'm just gonna finish this little section off, and then I'll
let's try.
End the stream.
To finish this, our first example, and what we are going to try is to move the sphere also vertically, in the other direction of the plane. In order to better understand this, we select the sphere, and
also I wanna move my camera back a little bit. You know what? Let's just like do this. I just want to do something like this. And look, now we got a top-down shooter. Actually, let's make this 0, 0. Actually, let's make it, is it 10? And the angle, let's make that a perfect 90. The Y is gonna be, is that right? Negative 160? Okay, and 160? 180. It should be 180, right? I'm not tripping out. That says 60. Correct? 160? Why would it be 160? But like what? But like why? 160. So if this is global, 90 would be down. Why? So 160. 90, and then if I go, oh. It should be wait. 135. What would 135 be? 135. I don't know. Why is that 160? Why? Why? 7, 7, 7, 7. Okay, so if I do 1, 1, why does that change it so drastically? I'm so confused. So 160. But like, why? I'm so... That's so weird. Wait, why? Background. Oh, okay. 160. What would be 0? What would 0 be? What? .360 is a circle, right? 180. If I do 1 degree, great. So it's like this, it's like this way. Okay? And then like 90 would be like this, right? No? Am I like wrong? Okay, great. So it is what I think it is. 90 is that. 180. What is going on, bro? What? What is going on? It was bugging the heck out there. It was bugging out there for sure. Okay, camera. Now that's like, that should be the center of the screen. It looks like it's a little bit too far over here for some reason. But let's just like expand that plane. And bang! Do it, buddy. Bang, buddy. Okay, no. Bang! Buddy, we got ourselves a top-down shooter. Let's move this light around a little bit so that it is okay. Let's actually move this light up. Let's do 15 meters there. And then 90 and 0, 0. It should be that is directly vertical. Okay. Now if I want to make it at an angle, am I gonna make it at an angle like this? If I do 180, okay, I do 135, and then I can, ooh, that looks nice. That looks nice. Now let's finish the gosh dang
You
section.
can see that now we are moving in this axis, in the x-axis, and now the objective is also to be able to move in this axis. This axis is the, as you can see in the gizmo, the z-axis, okay? So if we apply now a magnitude in the x, in order to move the sphere also in this direction, we will have to do something similar, in this case in the z-axis. So we can go back to the code again. So what it is clear is that, well, we have here the magnitude for x, the magnitude for y, and the magnitude for z. So we need to do something here, okay? So we are going to change this script a bit, okay? So what we are going to do is, what we have clear is that somehow we have to apply a magnitude also here in the z-axis, okay? So this is the idea. The point here is that instead of using horizontal, that it is detecting the left and right cursor keys or the left and right buttons of a gamepad, instead of doing that, we will have to use vertical. So in this way, we are going to be detecting the movement in the up and down keys, okay? So here we have the final script, okay? So very simple. We have to apply magnitude, again, meters per second, in this case in the z-axis, and in this case consulting the up and down keys, okay? So now we save, and we go back to the unit editor, and let's try to see what happens. Okay, so now we can move.
All right. X, Y, Z. Y would be up and down. But, sure, I tried to do that before. And it wasn't working. Why not, bro? What? Why was it not working? Okay. Okay, my speed is 0 currently. That's why. Wow. That's crazy, bro. That's wild. Oh. Oh, I like that little shading cut off there. Ooh. It goes from low fidelity, or it goes from high to low fidelity. Ooh, baby, I love that. I love that, baby. Honestly, I kind of want to know. I probably have to write a script to rotate the light around, right? Wait, I could just do the same thing, right? Yes. Yes. Okay. Light, rotate. Okay, now I'm going to Okay, so time.delta time. Now I'm going to translate transform dot translate. Do I have to do the capital T? Translate? Bro, am I like tripping the heck out? Okay, let's open this one then and see what I did. Transform, lowercase transform? I freaking, what? It didn't show up. Transform dot translate. Thank you. Okay, now what do I want to do? I want to change the the angle. Oh, wait. No, this, I want to do rotate. I want to do rotate. Oh, okay. So I just want to do Y. Correct. Yes, alright. Let's have this be, 45. No, 0. Let's have this be 0. So I'm just gonna do this. Vector 3 axis. Vector 3 Eulers. Yeah, this is the one I want. And then I want uh just do this. Oh, oh, oh no, no, no. And I want it to be Y, like plus, I don't know, plus 45 times time dot delta time. And then that should be it. Nice. Oh, and I actually didn't apply that. So let me just apply that. Nice. Now watch this. Oh my gosh, that is not what I wanted to do. That is absolutely not what I wanted it to do. What the fudge? Can I please get the light? Um, it said XYZ, right? X angle, Y angle, Z angle. So Y would be this, correct? Yes. Y, but like Y. Holy, what is going... Bro, it's freaking portaling my mouse. It's portaling my mouse on this screen. That's kind of sick, actually. Okay, I don't know why it's doing that. Why? Rotate. Okay, so I don't know why it would be doing that. Um, Z, what would Z be? Oh, Z does absolutely nothing. So I don't know why it's doing that exactly. But maybe I'll like switch these and I'll see if that works. I have no clue why it's doing this. Rotation X. Okay, so something is definitely going very wrong. I like absolutely do not want it to do that. Okay, look, why is it doing this? Like, it's rotating it around a center point instead of rotating it around itself. Okay, so that is actually not what I want it to do. Um, Around the given axis. Y would be vertical then. Or is X this way, Y is this way? Alright, let me try Z. I'm having so much fun with this. Okay. It's doing nothing as expected. Hmm. Okay, why is this not just one all across the board? Hmm. Translate. If I want it to translate, translate's not going to do anything unless I put it below the map. Like, this is global center, so it should be working, right? Like, it should be working. Global center, it should be working. it actually should be working. Like, that is not what it's supposed to be doing. That is not what it's supposed to be doing at all. Okay, so what is it doing? Let me think. It's rotating this way around the map, or I guess, you know, whatever. From your perspective, it might, okay. It, like, I'm mirrored from your perspective, but you got it. It's rotating this way. So obviously it's not the right kind of rotate, but it is doing something. Let's look at all the other transform dot. So transform dot. Okay, is rotate here? RS rotation. Rotate around local. What does this do? Rotates the transform about axis passing through point in world coordinates by an angle degree. Okay, great. Let's try rotate around local. Let's try rotate around local. Okay. Okay, and then obviously I need to do some other stuff here. Vector 3-axis float angle. So if I do Y, okay, if I do Y axis, okay, Y axis, okay, Y, never mind. I can't deal today. So yeah, that's it. That's the best I'm gonna get. But let's just finish this
as you can see,
section.
we can move in every direction right now using the cursor keys, okay? So we have achieved our first example.
Oh, and I can pause the script. Yes, okay.
Okay, now we have a problem. If you see, we can move the sphere and we can lose the sphere, okay? So the camera remains fixed, okay? As you can see, the camera is not following the sphere. In many games, games we call third-person games, it is very common to make the camera to follow the main character, in this case, the sphere. How can we do that? Well, this is very simple, and we can solve it even without changing the code. So now, remember, we have here the camera, okay? The camera is here, okay? We have here the sphere, and what we are going to use to solve this problem is something we already know, the parent-child relationship. So remember, if a game object is child of another one, if we move the parent, the child is going also to move with it.
Ah, okay. Okay, that's big brain. That's big brain. That is big hacking brain. All right. Boom. And there you go. We did it. Hello? Am I even moving the camera? Like, am I... Oh, I'm just going very slowly. Okay, we should see the top here. Yeah. I'm just going very, very slowly. Okay, I'm just gonna undo that.
Here we have the solution.
Because I don't
idea
like
is very simple. Let's go to the hierarchy. If we make the camera child of the sphere,
if we make the camera child,
if I move the sphere, the camera is going to follow me. Okay, let's see if this is the consequence. So we run. Now, as you can see, when moving the sphere, the camera is also moving with me.
Wait a
Okay? Very
second.
simple. This is very common in many games. And it has a very easy solution, as you can see. Using the parent-child relationship, we can make our camera to follow.
Okay.
If we want to undo this effect, we have just to select the camera and to move it outside. Okay, so again, we are going to have the camera in a fixed position. Okay, so with this, we have finished our first example.
Wait.
And we have still another problem we have to solve. As you can see, if I'm here, I'm not falling down. Okay, as you can see, we have solved this first example using kinematics. Okay, so this means that we are moving the sphere without using the physics engine. Okay, so if I'm here, because we are not using the physics engine and we are not using forces, of course, the sphere doesn't fall down. Okay, so this is one of the objectives we are going to try to solve in future videos. We are going to try to convert this example from kinematic to physics. And using the physics engine and forces, we will be able to get something similar, but as you are going to see, we will be able to get this kind of effect. So we are going to simulate the real physics, okay, of this environment.
Alrighty, cool. Wait. Is this actually the whole section? Oh, my brother, whoa. Okay, this was the whole section. This was the entire section. I still don't know why it's doing that, like, windshield wiper thing. But yeah. I am going to invite my father and brother up here to try my amazing new game called called Sphere. Alright, hold up. I'm just gonna have to wait a little while. Let me just read this here. Maybe interesting to modify the materials so that we can... Okay. This guy just speaks in such an atypical way. Okay, it's kind of weird, you know. All right, I am going to read this. Gosh, hacking dang, please. It may be interesting to modify the materials to more than simply change the color. We can search the internet for textures. Wow. Okay, to do this, we simply have to import these textures into Unity. Okay. Drag them from a folder to the Unity editor, specifically on the project view. Okay, great. Advisable to always create a specific folder in project to put these textures. That's not what I freaking wanted to do, idiot. Idiot brain, idiot hand, arm, whatever. Change back the color of the albedo. Okay, change the color to white. Oh, change the materials of the objects in the scene. Okay. We can apply this new texture that we've imported by dragging and dropping on the square to the left. Okay, sure. We're selecting it by clicking on the circle also to the right. The result must be that our sphere, cubes, or plane of the scene must now be dressed. Okay. I'm losing brain cells. Bro, I'm losing brain cells. Please. Okay, I'm just waiting for my brother to come up here. Get up here. Gosh, hecking dang it. Ging, 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 ging. Just reading through my Discord. All right, here they are. Here they are. You guys ready? You guys ready to see how far I've gone? Sit down and play. Okay, there's no sound, but okay, you just use the WASD keys. Okay, it's very simple. It's very okay. I meant to turn that I meant to turn that off. Okay. There you go. Now you can play. WASD, you ready? Yep. Nice. Sick. That's it. That's it. That's all I've done so far. Isn't that sick? I mean, I can make you go faster. And that's it. And that's it. There's food? Yes, I know. I know. Okay. Thank you. Sure. Alright, well, that's it for this stream. Guys, thanks so much for joining me. And I should probably look up how to change the name of my projects on Unity, but thank you guys so much for joining me, and thank you for spending your most valuable resource, the time in your life, on watching my stream. Goodbye.